So basically, this is the level editor code. It is part of the game code. It's part of the same repository, and it's written in TypeScript. So I can host it in the browser, and anyone could basically play with it and build their own levels without having to install anything. Now, the best place to start probably showing this is the app component. So there's this main file that basically calls the app component with the app. We're going to look in the app a little bit later. But basically, we have a split pane, and we have two areas, the editor area and the visual area. So we got, this is a split pane, and you can see it's split because we can move it around, right? This is split pane. And then we got the editor here, and we got the visual here. I call it the visual. And then we got the menus here. So this is the editor menu, and this is the visual menu. And so if I go into the editor, we can see that it actually says, I want to get updates to the text. So this is using React hooks. And I'm going to show this, how this is implemented in a second. So we got the editor needs to know if the text changed, obviously. It needs to know if the cursor, position basically changed. And it needs to know if the editor mode changed. The editor mode is basically if I'm in Emacs mode or Vim mode or whichever, right? And then there's another thing here that that basically when the cursor did change, we need to actually set this in a timeout. And this is kind of a little hacky, but that's the only way it works. Otherwise, we get these weird recursions of things happening. And actually, React complains if you actually do this within the render, right? And so this is just here basically where the editor is interacting with the app itself. Here, for instance, if we change the text via the editor, it's going to tell the app that the text changed. And obviously the app needs to know that because, as you can see, if I type, right, it immediately will update at this part on here, right? So it needs to basically know when the actually the text changed, and basically the level is the text, right? So there's nothing more but text that tells us about what the level contains. So the text is a source of truth, and this is basically just the kind of the visualization of it, and also a way to, it's a way, basically this part here is another way to edit text. You could think of it that way, right? Because we just basically like doing things over here, and then this means the text over here changes. So that's basically what that means. Here we have just some other settings, not too much. The font, then when the editor loads, we need to basically initialize the app with it, and we basically is just assigning the editor to a field here so we can interact with it later. That's pretty much the part of the editor. Now the visual is a little different. So we get the visual. Let me try to find the right one here. The visual TSX. So that one is somewhat similar. It basically gets the what am I painting, right? So this is like if I select, for instance, a wall, right? Now I'm painting walls. If I'm selecting the eraser, now I'm painting erasers. That's pretty much what that is. The cursor icon is derived from that, right? And then the cursor, I need to know where am I? So, right? So when the editor changes, right, we need to update the cursor here. And vice versa, if we change the cursor over here, then the editor syncs. So this is all kind of encoded in the cursor, even though in the visual you wouldn't call it a cursor necessarily, but it is kind of like a cursor. And then we go and look at the tile size, and the tile size is mainly used because if we zoom, we change the tile size to zoom what we're editing. That's pretty much that. Then this one is interesting here. We're using an effect, and we're telling React to only run it once. So once the component mounts, basically, which is what that means, only once, we'll basically pull out the canvas. So we have the canvas here, we're saying this is a canvas, and then we have a container element for the canvas. And so we pull both of these out, and then we tell the app that we want to create a new canvas, and this canvas is not a browser canvas. This is actually our basically just a canvas API that allows us to say, I want to kind of draw a rect, I want to draw a line, and so on, right? And this is what the app uses to interact with the canvas, which is actually in here, which is actually the real canvas, right? The browser canvas. And then the container element we need in order here to basically say if the editor is basically focused and it's moving around the cursor, we need to scroll this container element so it scrolls into view wherever we are. So if you're doing here, right, and we're moving around, this element needs to scroll to make sure that wherever we're editing is in view, right? So that's what that does. So that's those part. And now actually let's look at the app. There are lots more parts. And Commander, yes, it has some sort of Emacs or Vim or VS Code interface. You can actually select that. So you can basically select which mode you want, and this is the Ace editor, which basically is kind of an editor in the browser implementation, and it has different modes. And I was quite amazed, like what it actually supports even for Vim. I can basically make even a block selection like this, and I can say I want to move all this over, and then it just did that. And I don't know why it put those here. I don't think those are actually really there. Shouldn't have done that, but you can basically move things. Or I can even, what I could do is I can get myself a little more space over here by moving this over, and then I can copy this one out. Right, I can copy that out, and I can just paste it over here. Boom, and then I just copied this whole thing. So I figured that this is kind of a nice power user way of editing levels, versus this one is a little more intuitive, but it doesn't give you quite as much power, right? So that's why I did it this way. Now let's look at the actual app controller. That's the most important part probably of the whole thing. So the app controller is kind of like it's the controller of the app. It has everything in it. It has some subcontrollers inside of it, but most of the logic actually happens here. And it uses this thing called event effect. And that's like an interesting thing. So I'm going to show that first. And Commander, thanks for stopping by. I'll see you in the next stream. So the event effect. So this one is I kind of wrapped the using a effect kind of React thing in this to be able to use it a little better. So basically what this means is that I want to be able to do the following. I want to have whoever says use editor text is basically getting updates about the text. It's kind of like if you're coming from like maybe the .NET world, it's kind of like an iNotify property changed, or like a dependency property, or if you're coming from like thinking about streams, it's kind of a stream of text, right? So every time the text changes, I want to basically whoever here says use text, right? This text will keep updating, and then this the React basically makes sure that the render function runs again, right? So but then I also wanted to be able to easily control this text from the outside, right? So I want to be able to say set text, and this is actually what we're doing here. We're doing this with the cursor, here we're doing it with the text, right? Set editor text. So the problem is when you're using this effect thing, it's kind of hard to get into the function to call it to set. So I didn't want this guy to manage this, right? The usual thing is you say use something, right? And then you get a set method and you get the actual values. But I did not want my views to actually directly set things, because in some cases like here, I want to actually do other side effects or I want to maybe keep state or something whenever that happens. So I want to control it in the app controller. That's why it's a controller. I don't want this to happen outside. And multiple things could maybe want to set the text, right? But then I have to do the same thing in each case, and I don't want to have to manage that outside of the controller. So basically what this means is that, okay, I'm doing the effect. I need this because this is basically what hooks together this event. So And then I'm saying this is the original value, the initial value, and then this is the callback every time that basically set editor text is called. And it's kind of an odd way of using React hooks, but it worked out really well for me. So basically how this is implemented is basically I'm creating this effect. And what I'm basically doing is that if the owner basically emits this event that we just looked at, like set editor text, then I basically handle the event, which is doing nothing else but setting the state like you would normally do, like the set state is here, right? And then it also calls on event, which is basically the callback that we just looked at. So the controller then can react to that outside of what React does. No pun intended there. So it was a weird sense, but so the owner, basically the owner can do other things instead of just having React update the state inside of it. And then here's like whenever the effect is basically collected or whatever, we want to turn off this subscription, right? We want to unsubscribe from this event. Then we just use the effect and we return the state. And so now we can do this. This is the main thing inside that editor. And that is pretty much all I wanted to show, I think. One kind of nifty thing we can do is we can actually now go and since there's a URL, right, I can basically convert a file, right? Okay, so there we go. That's the other thing I wanted to show. We need to look at the level encoder. So how does this work here that we are having this short URL, and the short URL encodes pretty much all the stuff that's in here, right? How does this work? Well, there is a level encoder that I implemented. So we're going to look at that next. So level encoder. So that friend is basically just a small little class that does nothing but convert a level to the string that we looked at, right? And what it does, it uses URL safe cars. And how does it do that? Well, it uses a 6-bit encoder that I actually implemented. So let's actually look at that one real quick. I hope it'll find it like that. Yes, there you go. And so what that does, it has a slightly adapted base64 encoding, where it's basically base64, but there were some characters, or maybe one or two only, that were not 100% URL safe. And so I basically, made it encode only the ones that are actually safe. So this is the encoding table. So what it means is you give it an integer from 0 to 63, and then it gives you whatever the values in that table, which means then you get values like that for these integers, right? And you can see that since numbers are first, that the first numbers from 0 to 9, right? They are actually coming out the same, right? They are kind of identical, and so that's what we're using in here. So what we're doing basically is we're looking at the editor content, right, the text, and we're converting it first to hexadecimal number, or like numbers, right, any number. So this is the empty. So basically, if if you have like nothing in here, right, empty right there, for instance, that's basically encoded as 0. Then if you have a new line, is 1. X is basically if we have the universe, right? If we want to have the universe shining through, that's X. The player is P. Then the vols are equals. Then we have the health medkit, which is not 100% implemented yet in the game at least. And then we have a shield. So, and then we have another way of doing this backwards. So we can have tile to hex. So if we give it basically one of those tiles, one of those letters, it will convert it to hex, and then we have hex to tile, which is the other way around. And then basically we have a max repeat, because we can. What we're basically doing is, if we have one space, but we have, we don't want to have like a letter or a character for each space. That's wasteful. So if you actually count like 10 spaces in a row, we're just going to say 10 space. We're not going to like say space, 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 right? And but then we have a max repeat, because we cannot repeat more than 64, because we cannot express a number higher than 64. We cannot say 65 times space, because 65 doesn't exist in the 6-bit encoder. And so 6 bits also means, by the way, that we only have 6 bits, right? So the highest number in that case is 64, right? So and then basically what we're doing is we're doing a few steps. First of all, we consolidate, which is exactly what I just described. We are basically taking we're splitting first into lines, and then we're going through each of those lines, and we're looking at what's the current car in this line. And if the current, the one that we just looked at, is the same, which is the case here, then we just count. We update the count, right? So okay, now we saw 3 spaces, now we saw 4 spaces, now we saw whatever, right? However, the first time, obviously, we need to initialize to the current tile will be C, and the count is 1, right? Because now we counted 1. And then here we update the count up here. And then if you have a new tile, we basically push the current count and the current tile to our array. And then we start over, basically. And what's this one here is basically this is basically after the loop, right? So if we still have a current tile, obviously we need to still push it if you just dropped out of the line. And that's what we do. And then we basically just push a new line. And that's pretty much it. And you can see why am I doing 0 and count -1 here? Well, because we are counting starting at 1, like we have 1 space. But since we are encoding from 0 to 63, like we cannot have the number 64. We have to go from 0 to 63, so we kind of correct that whenever we push this. And then basically all we're doing is we consolidate, and then we stringify 6 to 6-bit, which means basically we are we're just going through the counts and the tile, and we're converting each of those to basically a hex number. So the tile hex, right, has to be whatever the character is in the tile. So for instance, space will then become something else. And if you don't know what that tile is, you just say, well, it was empty. So that kind of, if you type something into the level that we don't know yet, like a character that's unknown, like then we'll just assume that it was nothing. And then we basically encode this tile hex with the basically this is the encoder function from 6-bit encoder, which basically says, give me a number, right? In this case, we think of it as hexadecimal numbers, and then basically I will give you one of those URLs, say cars. And then we can see that we take whatever we had so far, we encoded the count, right? The encoded count is really simple because you just take the number and also encode that into a car, and then we add the encoded tile. So if you look at it here, we can see that it's P4, right? So P4, this is like the first one here. So P would mean like however many of those are. So we can look actually into the code, and we can look at what's P actually. So P is right, just an uppercase P, so it's like roughly 25 or something, right? So we got 25 of 4, and 4 is basically what we encode the walls with. And if you paid attention, you can see that's true, right? So we get basically 25 walls like that, and then it basically has the new lines are encoded with a separator, which is a star, because the separator we only can have one new line. It doesn't make sense to always say one new line, so we just have a separator. And then we start with the next one. So we have, I think this says 0, right? But actually we know that we subtracted 1, so it's 1, 4, which means 1 wall. And then we got n, n0, which means we got n spaces, whatever n is, right? N in this case is like something like 24, and so we got n space, and so on. Like, so this is how it basically encodes it. And when we decode, we just go basically the other way around. I won't walk through this code here, but it's basically just reversing the process to get back at the string that we originally had. And that's the level encoder. And so what we can do now is we can basically go and write us a script, which I already did. So if we look at this is the core, and we need the level editor. So we have scripts here, and basically have an open level script. Is there a bash mode? Let's see. I guess not. Okay, now that looks better. Oh no, this is actually JavaScript. Haha. Yep. So this is actually JavaScript. Basically, what this does is this: it takes a level encoder, and then what it does, it reads the file that we give it as the first argument, and then it looks at if you give it a special URL, and if you don't give it a special one, it assumes the editor URL. And then it logs those out just to make sure that we get the right thing. And then what it does, it basically reads the file that we give it, which could be like a level that we're working on. It then encodes it, and then it says, open this, encode it. So basically what it does, it like generates this URL with the level encoded, which means we can easily now create a level and just have it open up. So what I'm actually going to do, I'm going to demonstrate that because we're actually going to probably use that when we now edit the level. So what I'm going to do is I'm going to make this the only window. And so what we could do is move this over here. And we can actually move this guy close up to the right. And we can actually move this guy to the same. Whoops, it just disappeared on me for some reason. There it is. And we can move that over here. And we can make the editor really small. Maybe I built in an option to just get rid of the editor because we won't use it in this demonstration. So what I can do though is I can say edit. So I'm going to do face off. I'm going to take that, call it a face off. That's the level. And so now, for instance, I can start with something here, and I could put this in, right, like this. And then copy that line there, and then maybe copy that line a few times, and I got my level. Put a player there. Okay, so now how do I get this to open over here? Well, what I can do, I can run the script that I just showed as a compile command. So I can define myself a compile command. Oop. I can say basically what do we call this thing? Call this open level, right? Okay, so, and I don't know what's going on, Emacs. So I can make myself a compile command, and it says open level, and then I say face off, and if I'm in the right folder, then this should just work. And that didn't work. So we have a bug actually in the script. It should be cheeselawrence.com. All right, so that's the only problem. So actually what I'm going to do is I'm going to open level. I'm going to fix it. That's actually the real URL. So now if I run the compilation again, it opens the level. And as you can see, unfortunately, it always does it like this, but we have our level open here. So we can easily just like, whenever we edit, have it reopen like that. Now what we could do in order to maybe have this make a little more sense, we can actually maybe move this window, move the Emacs down, move this guy up, and make it wide, right? And then make this guy go down here, right? And then maybe move the compiler, move that to where I make, okay, well, I don't see anything anymore. So that's interesting. So what I actually want to, I ended up in a different project somehow. So I want to get the face-off level. Okay. So we can have it kind of like this, and I can basically have the compile and save command or something like that. It's called save compile. Oh, there was auto compile on, yeah, compile on save mode. So now basically every time I save, it will open the level up here. And you can kind of see that it's a little annoying to have this like that. But basically what we could probably do, we can just move our browser window also like that. Well, basically there's numerous ways how we can work around this for now, and then maybe have another reason why we want to maybe update the level editor. So we can move one, open it again, and as you can see, it's like that. So what I'm actually going to do is I'm going to make this bigger, move it here, and make this even bigger. Move it here, so we basically got the part that we want, and it's hacky. It's a hack around the limitations. But I don't even know how long we will keep working like this, because we can also basically go into this editor directly. But if you want to kind of stay in Emacs or whichever editor we like, in the real editor, we can do it like this. I hope that makes sense. So, and then obviously we probably want to move that one here to a different. This is not what I was trying to do. There was another way. Well, yeah, there was another way to move this around, but it's fine.